Good morning, students. Today we learn inverse trigonometric functions. So in this chapter, first I have to recall the first PUC concept in trigonometric functions. As you know, there are 6 trigonometric functions. So let me write first 3, which are sin x, cos x and tan x. As well as you know, these trigonometric functions, sin x, cos x, tan x and our remaining 3 are not bijective. As well as you know, to define inverse function, the function should be bijective function. So why sin x is not bijective? Because sin x is not 1 as well as not onto. So because of this problem, you can't define directly the inverse of sin x, cos x, tan x, secant x, cosecant x and cot x. So first of all, we should obtain a bijective trigonometric function. So how to get the bijective trigonometric function? To get a bijective trigonometric function, its domain and range should be adjusted. How to adjust? In sin x, the domain must be minus pi by 2 to plus pi by 2. Why it must be minus pi by 2 plus pi by 2? As you know, f of 30 degree, that is sine 30 degree, as well as f of 150 degree, that is sine 150 degree, both will be is equal to half. So two different elements mapping to the same element, it's not allowed in one function. So to avoid this, you should take the domain less than 90 degree. Similarly, f of minus 30 degree as well as f of minus 150 degree, both will be is equal to half. So again in the lower end, you should take from minus pi by 2 to plus pi by 2. With this restricted domain, you can have a bijective sine function, minus pi by 2 to plus pi by 2. Range, as you know, it is nothing but minus 1 to plus 1. So this is bijective sine function. So using this bijective sine function, very easily we can define its inverse. As you know, if f of x is a given function, its inverse is denoted by f inverse of x. So using this basic notation format, we are going to today define the 6 inverse trigonometric function, in which the first one, inverse of sin x or sine inverse function. So you know, when you define inverse of a function, you are going to interchange first domain and range. Here what is the domain of sin x? Minus pi by 2 to plus pi by 2. Range is minus 1 to 1. When you are defining the inverse of a function, first you are going to write range as a domain. What is the range here? Minus 1 to 1. When it comes to this inverse function, this range will become domain. So domain of first inverse trigonometric function, which is sine inverse of x, is minus 1 to 1. What is the domain in the sine function? Minus pi by 2 to plus pi by 2, and that domain will become range for sine inverse of x, that is minus pi by 2 to plus pi by 2. So now we can define inverse of sine x as follows. It's a function f inverse from minus 1 to 1 to minus pi by 2 to plus pi by 2, defined by f inverse of x is equal to sine inverse of x is equal to sine inverse of x. Sin x is trigonometric function and its inverse is defined as sine inverse of x. Yeah, this is the first inverse trigonometric function called sine inverse of x. Similarly, exactly same pattern, we are going to define inverse of cos x. Again, the same problem is, so cos x is not bijective. The reason is again, it is not 1 as well as not onto. So we have to restrict its domain and range. How we should restrict? As you know, cos 30 and cos 330 both are same. It is root 3 by 2. So it should be more than 0 and less than 180 degree. So with this restricted domain for cos x 0 to pi, Range is as usual, it's minus 1 to plus 1. It will be a bijective cos function. With the bijective cos function, easily you can define its inverse. So what is the domain? Domain must be between 0 to pi. When it's more than 180 degree, it will give you the same value within between 0 to pi. So take from 0 to pi as a domain for cos x. Range is again same, minus 1 to plus 1 only. With this restricted domain and range, you can have a bijective cos function. So as usual, for a bijective cos function, to define its inverse, you have to interchange first domain and range. How to interchange? Okay, what is the domain here? 0 to pi. So here it must be a range. So it is 0 to pi. What is the code range? Minus 1 to 1. So range must be minus 1 to 1. How to define? F inverse of x is equal to cos inverse of x. So therefore, the definition of cos inverse of x is as follows. It's a function f inverse from minus 1 to plus 1 to 0 to pi defined by f inverse of x is equal to cos inverse of x. With this bijective function, the inverse of cos inverse x is defined as follows. One more, the next one, which is a third trigonometric function, tan x. Again the same problem. It is also not a bijective function, because again the same problem, it is not 1-1 problem. 1-1 function. It's not a 1-1 function. Okay, why it is not 1-1? As you know, tan 30 is 1 by root 3. Tan 210, it is also 1 by root 3. So two different elements mapping to same thing. So it is not 1-1. Since it is not 1-1, with this original definition, you cannot define its inverse. So we should have first a bijective tan x. How to get a bijective tan x? Yes, restrict the domain and range. What is the domain originally? R. So with R, you can't have the bijective tan function. So restriction is as follows. Minus pi by 2 to plus pi by 2, not including pi by 2 and plus pi by 2. Why it is not included? Because as you know, tan pi by 2 does not exist. Similarly, tan of minus pi by 2 is also does not exist. So excluding minus pi by 2 plus pi by 2, if you take this domain, in this domain tan x is a bijective function. This range, it is same as that of tan x, which is minus infinity to plus infinity. So this is a bijective tan function. This is bijective tan function. So as usual, to define its inverse, first of all you have to interchange its domain and range. What is the domain here? Minus pi by 2 plus pi by 2, and it will become minus pi by 2 plus pi by 2 as a range, and record range is minus infinity to plus infinity, and it will become domain of its inverse, that is minus infinity to plus infinity, and defined as f inverse of x is equal to tan inverse of x. So how to define tan inverse of x? It's a function f inverse from minus infinity to plus infinity to minus pi by 2 plus pi by 2 defined by f inverse of x is equal to tan inverse of x. Thank you.